Okay, this is the notes for Unit 9, Day 5. Unfortunately, this would be the third time I'm trying to record it. First time the program crashed, and the second time there was no audio. So, if you know, I do have all the notes written out. Unfortunately, I'm all out of copies, and I just don't want to print another copy, but I will explain these as I go. So, first off, we're going to be adding and subtracting expressions, and think when you add or subtract fractions, because a rational expression is just a fraction, you have to have common denominators, and a lot of times the common denominator, if they weren't already the same, the common denominator was also the least common multiple. Okay, so least common multiple is synonymous with common denominator. So let's pretend like you had two fractions. One had 9 on the bottom, one had 6 on the bottom. So to find the least common multiple, in its numbers, you guys could probably just kind of in your head do it. Think multiples of 9 are 9, 18, 27, 1. Multiples of 6 would be 6, 12, 18, 24. And looking at that list, 18 is in both lists, and it's the smallest one. So that would be the least multiple they have in common. If you remember from middle school, the faster way of doing that is looking at the prime factors. So if we look at 9, the prime factors are 3 and 3, which would be 3 squared. And then 6 is 2 times 3. So from looking at these two and thinking these are two individual lists, look at out of those, I see 2 somewhere and I see 3. So list any factor you see in either list. It doesn't have to be in both lists. It just has to be in one of the lists at least. So 2 is in one of the lists, and 3 isn't actually in both lists. Now look at the highest power. So the highest power I see on a 1 is a 1. The highest power I see on a 3, the highest power on 2 is 1. I'm not sure what I just said. But the highest power I see on a 3 is a 2. So 2 gets written down. Okay, so if it's in the list, it gets written down, but then you write down the highest power that goes with it. So 2 times 3 squared would be 18. Okay, so here 12 would be 2 squared times 3, 18 is 2 times 3 squared. And you can do the factor tree if I'm going too fast with that, but when you get to your turn you can do factor tree. But so I see 2's and I see 3's. Again, it doesn't have to be in both lists, it just has to appear. And the highest power that goes with them, the 1 power is a 2, 1 power is a 1, so the highest power is a 2. Between the 3's, it's a 1 and a 2, the highest power is a 2. So 2 squared times 3 squared is 36, and that happens to be the smallest multiple that 12 and 18 have in common. When it's numbers, it's kind of easy to do. As we get into letters, it gets a little more difficult. So x cubed, would just be x cubed. 3x would be 3 to the first, x to the first. So I see 3 and I see x. Those are my bases. So 3 and x, the highest powers then are 1 and 3, because x has a power of 3 here, 3 has a power of 1 there. So 3x squared would be the least common multiple. Okay, so here at 2 times x squared, 4 is 2 squared times x. So I see 2's and I see x's. Their highest powers are 2 and 2, because that one has a 2 and that one has a 2. So 4x squared would be the least common multiple of 2x squared and 4. I could just multiply this by 2, and I can multiply that by x, and now I got 4x squared. They both would equal 4x squared, and I could add them if they were denominators. Getting a little crazier now. This I cannot do in my head at all. I'd have to do the factoring. Maybe some of you could do this kind of in your head if you're good at it. But so x squared plus 3x minus 2 would be the same thing as x plus 5 and x minus 2. Again, that's just from the product has to be negative 10 and the sum has to be 3. So it must be positive 5 and positive 2. Over here I pulled out a 6. Okay, so I got 6 times x plus 5. So the factors I see, which 6 goes into 2 times 3. So I see a 2, I see a 3, I see x plus 5, and I see x minus 2. Those are all the bases in the list. Now I write down the highest powers. Well, the highest power I see on any of them is a bunch of 1's. So that would be my least common multiple, all of them to the first power. Okay, this guy, do some factoring, take a 2 out of everything. And then once I take the 2 out, now that would be x minus 2 times x minus 2. Again, product is 4, sum is negative 4. And then over here, take a 15 out of both of those. So it'd be 15 and x squared minus 4. And then x squared minus 4 is a difference of 2 squares. So that goes down to x plus 2 and x minus 2. So all the factors I see 2's, I see 3's, I see 5's. I see x minus 2's, and I see x plus 2's. So write all those down. Now the highest power on any of them would be a 2, because this one right here, this is actually squared. X minus 2 times x minus 2. So 2 times 3 times 5 is 30. X minus 2 squared times x plus 2. And that would be the least common multiple of those two. Okay, which just means I can multiply this by something, I can multiply that by something, and have the same result when I'm done. Okay, so now let's practice a few. These first two already have the same denominator, so we don't have to do what we just did above for a little bit. So these have the same denominator, x plus 3 and x plus 3. That means my answer is going to be over x plus 3. Remember, when you're adding fractions, you don't add the bottoms, you only add the tops. Now when I add the tops, though, I got x plus 3x is 4x, and then 1 plus 11 is 12. Notice out of there, I could take a 4 out, so it's actually 4 times x plus 3. And since there's an x plus 3 on top and an x plus 3 on bottom, I can cancel them. Now I got 4. Your restrictions, now remember, think back, what would make the bottom equal 0 in the original problem? So in the original problem, negative 3 would make that equal 0, so I have a negative 3 there. Number 2, both over 5x, so the answer is over 5x. Whenever you're subtracting, that means add the opposites, so I switch this to add, and then I switch these to negatives. So 6x minus x is 5x, 7 minus 9 is negative 2. Nothing factors out of here, which means I cannot cancel. I can't cancel the 5x and the 5x because 5x on top is not a factor. On bottom it is, but not on top. So I can't do, so that's my answer. I can't reduce anymore. And what would make the bottom equal 0? 0. Okay. I'm going to skip number 4. Okay, the one denominator is x, the other one is 2x. So that means the common denominator would be 2x. I see 2's and I see x's. They're both the first power, so it would be 2x. This one's already 2x. This one needs to be doubled so that it matches. But if I double the bottom, I got to double the top. Okay, so 6 over x becomes 12 over 2x. 12 over 2x plus 3 over 2x equals 15 over 2x. Okay, can't be canceled or can't be reduced. X is not allowed to equal 0. Okay. Number 5. I got 9, and look at the black here. I got 9 and I got x. So the least common multiple, well, this is 3 squared. This is x. So I see a base of 3, I see a base of x. The highest power on 3 is squared. So that'd be 9. So 9x. Up here, to get them to be 9x, this needs to be multiplied by x. So if I multiply that 9 by x, I get 9x. So I got to multiply the top by x. The second one, it needs to be multiplied by 9. So I got to multiply the top by 9. Okay, so what I've done down here, 4 times x is 4x. And then I distributed the 9. I think I'm ahead of myself. Let me write this again. So I got 4x minus, and then in parentheses, 9 would be negative 18x plus 18, or plus 9. And then I switched the signs. That's how I got what I had below. So hopefully that makes more sense. So we got 4x plus 18x is 22x, and then I got that minus 9 in there, so minus 9. Nothing factors out of the top, so I can't cancel. Don't cancel the 9's because 9 is not a factor of the top. Okay. Now, the original denominator, 0, would have made it equal 0, so I can't have x equal 0. This guy, the original was 2x plus 14, which I factored into 2 times x plus 7, and this one's x plus 7. They would be the same if I doubled this one. So 2 times x plus 7 is my least common multiple. I got to double the top and the bottom here. So 3x plus 1 plus 8 minus 2x. Okay, so 3x minus 2x is x. 1 plus 8 is 9. Nothing cancels. What would make the bottom equal 0? Negative 7 would, so x cannot equal negative 7. I didn't do all the problems in the back. I tried to save some time here so that the video was getting kind of long, so I just kind of skipped. I did half of them on the back. So this one here, the original denominator was x times x minus 4, and this one was x minus 4. So it's missing an x. So that means the least common denominator, or least common multiple, would be x times x minus 4. That needs to be multiplied by x. That needs to be multiplied by x. So x minus 24 plus 5 times x plus 5x. X plus 5x is 6x minus 24. Notice they're both divisible by 6. So I divide them by 6. So 6 times x minus 4. Well, there's an x minus 4 on top and bottom. That's where I cancel those out. Okay, and so I get 6 over x. Now when you're doing your restrictions, remember it has to be the original denominator, not the reduced, not the simplified denominator. This was the original denominator. 0 and 4 would make it equal 0, so that's part of the restrictions. Okay. So just because a factor cancels doesn't mean that that restriction is canceled. Number 10, x squared plus 3x and x plus 3. Well, if I factor this guy, I get x times x plus 3. It means if I had an x with that one, they'd be the same. So x times x plus 3 is that common denominator. Multiply this by x, multiply that by x. 8x minus 1 minus 5x. 8x minus 5x is 3x minus that 1. Looking, does anything cancel? Even though I've got x's on top and bottom and 3's, none of those are a factor at the top, so I can't cancel. Nothing factored out of the top. Okay, so this one stays the same, and now 0 and negative 3 cannot, or x cannot equal 0 and negative 3. Number 11, again, look at the original. Try to ignore my work right now. I had x minus 2 and x squared minus 3x plus 2. Well, let's factor them first. So I factor this guy. It'd be x minus 2 and x minus 1, because negative 2 times negative 1 equals 2. And yeah, so I got x minus 2, x minus 1. Here's x minus 2. It needs an x minus 1. Okay, so that's my least common denominator. So that one just needs to be multiplied by x minus 1 on top and bottom. So this is 2x minus 2 minus the 3. So it'd be 2x minus 5. And nothing factors out of there, so you can't cancel. So that's my answer. X can't equal 2 or 1. Okay. And then number 14, this guy here, I got x squared minus x, which would be x times x minus 1, and then this one over here is x plus 2. They don't have anything in common, so I really just need to multiply all three of those together. So my least common denominator would be x times x minus 1 times x plus 2. So what's missing? Well, this has the x and the x minus 1. It needs an x plus 2, so I'm going to multiply the top by x plus 2. This one has the x plus 2. It's missing the x and the x minus 1. Okay, so now negative 5x minus 10, that's this guy, plus, and then x times x is x squared, x times negative 1 is negative x. So add those to get all that together, you get x squared minus 6x minus 10. Okay, and you could try to factor that. That does not factor. There's no numbers that multiply to give you negative 10, add to give you negative 6. So that one, there's nothing can cancel because that factor. And then x cannot equal 0, 1, or negative 2. Okay, so that was kind of fast since everything was written out. Hopefully, if you had questions, you can pinpoint when you had it and maybe ask me and I can try to explain it in a video.